Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question.
Today's question is MAXMINMEX. In this question, we're given an array A consisting of n distinct integers. Now we need to arrange the elements of A to form a new array P, which is nothing but a permutation of A. And for this permutation P, we can construct a sequence of prefix ranges where the ith element is defined as max up till the element I minus the min up till the element I. Now our goal is to maximize the max of the sequence R. So for example, if this is our array A, then the R of phi for this array would be 1 minus 1, that is 0. Now the max up till this index is 4 and the min is 1, so 4 minus 1 is 3. Now the max is 4 and min is 1, so 4 minus 1 is 3. Over here also the max is 4 in this range and the min is 1, so it would be 3. And for the full array, the max is 7 and the min is 1, so it would be 6. Now the max of the MEX of this array is going to be equal to 1 because that is the minimum element which is not a part of the sequence, right? Now let us see for the second one. So in this one, the R1 is going to be equal to 0, which is 1 minus 1. This is going to be equal to 2 minus 1, which is 1. This would be 4 minus 1, that is 3. This is also going to be equal to 4 minus 1, that is 3. And this is going to be equal to 7 minus 1, which is 6. Now the max of this second array is 2, which is the minimum element, not a part of the sequence, right? Now we need to rearrange this element and we need to maximize the value of this max that we get. And now for the maximum value of this max, we need to find the number of distinct permutations P of the array such that the resulting max is the maximum possible. So we need to find the number of distinct permutations which gives us the maximum possible max. Now the answer might be very large, so we need to print it modulo this number. Now these are the constraints where the number of test cases is in between 1 and 10 raised to the power 5, n is in between 1 and 2 into 10 raised to the power 5, ai is in between 1 and a billion, and all the elements of the array are distinct. And the sum of n over all the test cases does not exceed 2 into 10 raised to the power 5. Let us once see the sample inputs. So in the first input, we are given 1, 3, 2, 1. So we can arrange it as 1, 2, 3, 1. Okay, we can also arrange it as 3, 1, 2. We can also arrange it as 2, 1, 3. And we can also arrange it, 2, 3, 1. And we can also arrange this as 3, 2, 1. Now, the R array for this would be 0, 1, and 2. For this, it's going to be 0. Then 2 minus 1 is 1. Then 3 minus 1 is 2. For this, it's going to be 2 minus 2 is 0. 3 minus 2 is 1. And 3 minus 1 is 2. For this, it is going to be 3 minus 3 is 0. 3 minus 2 is 1. 3 minus 1 is 2. And the max in each of these cases is equal to 3, which is the minimum excluded element, right? And we got a total of 4 permutations of this array, which is the answer for this particular case. We can also generate another permutation, let's say 312. Now the R array for this permutation is going to be equal to 0, 2, and 1. And the max for this one is going to be equal to 0, 2, and 2, right? Now the max for this particular array is going to be equal to 1, which is not the maximum possible, right? Now for the second array, we have 11, 1, and 10. And you can just figure out that there would be 2 permutations, which would give us a maximum possible max, which would be equal to 2, I think. For this one, there's just one element, so there would be just one permutation. So the answer is easily 1. And you can just try out for the last test case and we'll move to the solution. Now let us try to first of all maximize the value of MEX, this max, and then we'll try to count it how many permutations with that particular max exist, right? So we have R of I equal to max I minus min I, right? So let's say if this is the ith element, then the maximum element up till this minus the minimum element up till this index, right? So can we say that this R of I is going to be an increasing sequence? Because as I move forward, this max value, this max of I is going to increase, right? Like up till here, if the max was 8, then over here also it would be 8, 8, and then here it would be 9. So it's a non-decreasing function, right? So it would be like an increasing function. And min of I would decrease, right? So it's a non-increasing or like a decreasing function. So this max minus min would obviously be an increasing function, right? Or like a non-decreasing function, right? So if I have my R of I like this, so if I let's say got 0, then I let's say get a 1, and then let's say we get a 3. So is there any possibility of getting a 2 in the future? There isn't, right? Like I'll never get this 2 in the future. So the max of this particular R array would become equal to 2, right? So like the whole idea of telling this is that on adding the elements, if I skip this 2 at some particular index I, then I'll not get this 2 in the future, right? And this gives us a hint to calculate the possible value, the maximum possible value of x, right? So like we'll try out some observations. And one of the very first observation that you would have probably got while solving this question would be that let us try out some consecutive elements, right? So if let's say we have this kind of array, then let us try to get like let us try to put 1, 2, 3, 4 in the beginning consecutively. Right. So to maximize the max, we are claiming that all the numbers must be consecutive, right? So we're first of all, like it's just an observation that the numbers should be consecutive, right? Because if I have 1, 2, 3, 4, 5, it would be 0, then it would be 1, 2, 3, 4, right? So this would give us maximum possible max. Like the longest such sequence would give us the maximum possible MEX. This is just an observation as of now. We just need to like prove this somehow. Right. So let us assume that it is not consecutive, right? So we have 3, 4, 5, 6, 7, 8, 9, 10. Now, over here, if this is consecutive, then the maximum possible max would be 0, 1, 2, 3, 4, 5, 6, 7, 8. Right. For this particular thing, if all of them exist, then the possible maximum possible max that we can get would be equal to 8, right? But let us say this 7 is not present, right? So what would happen? The difference between the maximum and the minimum element would at least differ by 2, right? Like I was able to get a 0, a 1, a 2, a 3, but I'll never be able to get this 4 because it is not consecutive after that, right? Now you can just try to think more about it and you'll be able to know that, okay, it must be consecutive for the max to be maximum of our sequence RFI, right? So like so far our observation is that for the max to be maximum, all of these numbers should be consecutive. So what would we do? Right, we'll try to find out the longest consecutive sequence, right? And that we can easily do. How do we do that? We'll just simply sort the array. We'll run a loop and we'll see that are these elements consecutive or not. If they're consecutive, then just keep increasing the count. Otherwise, just reset the count and take the max across all such possible counts, right? Now, let us say that L is the length of the maximum possible consecutive sequence, right? So let's say we have placed some elements 1, 2, 3, 4, 5 over here, and then there are some other elements which we are placing over here, right? So once we have placed all of the elements here, can we place these elements in any order? Right. So let's say we have 10, 11, 12, 13. So we have placed these 10, 11, 12, 13 here in the beginning. So can we place these elements in any possible order? We can, right? Because the maximum possible max would be 4, and that we have already got, right? We have got 0, 1, 2, and 3. And because we have got 0, 1, 2, 3, the max would be at least 4, right? So how many ways exist to arrange these elements? It would be n minus l factorial, right? Now, how many ways exist to write this thing, right? So let us say that we are trying to put in 10 to 13. Now, how many ways exist to put on these 10 to 13 such that the max because of these elements in our array R is going to be equal to at least 4? So how would we do that? So see, the last element has to be either a 10 or a 13. Why? Because if it is not 10 or it's not 13, that means the max is not changing. Right? Because 10 means the minimum element. So we are adding a new element. So let us say the minimum element up till this index was 11. Now, if it is not 10, then if it is, let's say 12, if we put a 12 over here and the min up till here was 11, then what would happen? 13 minus 11 would be the minimum, right? So the max till this element, like the R of I up till this element was 2. And over here also it would remain 2, right? So to change the value of R of I and add a new element, it has to be either the minimum or the maximum, right? So let's say we place a 10 over here. Now, what are the possibilities for this? Again, it has like our range changed from 10 to 13 to 11 to 13, right? Now again, we have just two possibilities, either place a 11 or a 13. Or let's say we place a 13. Now here are again two possibilities, either place an 11 or a 12. So let's say we placed a 12. Now here's just one possibility, so we'll place the 11. Now what is going to be the R array for this? First would be 11 minus 11, which is 0. Here it would be 12 minus 11, which is 1. Here it would be 13 minus 11, which is 2. And here it would be 13 minus 10, which is 3, which is perfectly what we wanted. Now the max for this would be, right. So what are the number of such arrays that exist? There would be two choices for every such index, right? For every such L minus 1 index. So how many total arrays can we get? It would be 2 raised to the power L minus 1, right? So what are the total number of arrays that we have now? 2 raised to the power L minus 1 rearrangements for this, n minus L factorial for this, right? Now let us just consider one last case. So we had 10, 11, 12, 13 over here. But we could also have 1, 2, 3, 4 placed over here. Right, and there could be multiple such possible consecutive arrays which we can place. So what would we do? We'll just count it how many such L length consecutive arrays we can have. So in this case, we can have two such arrays, which would be 1, 2, 3, 4, and the other would be 10, 11, 12, 13. Now notice that all of them would be distinct because they are of maximum possible length and all the elements are distinct. Right, so we would have like non-overlapping such number of arrays, right? So there would be 1, 2, 3, 4, then there is 10, 11, 12, 13, then there could also probably be 15, 16, 17, 18, right? And all of them are non-overlapping, right? So you can easily iterate over the array and count how many number of such arrays exist. Now what would be our answer? It would be 2 raised to the power L minus 1 into n minus L factorial into count. What would be the time complexity of n? Right, because we're just iterating over the array and you can easily calculate this thing in maximum of O of n. You can calculate this in maximum of O of n, and you can calculate this as well in maximum of O of n. So the overall time complexity would be order of n. Now let us see the solution in C++ and Python. So yeah, this is a solution in C++. We'll begin by taking in the input of all the test cases. We'll take in the input of the array. We'll sort the array. We'll calculate that what is the length of the maximum possible consecutive array. We are just calculating the length over here. So this max will store the value of L that we discussed in the solution. And this current would store that what is the current count of the consecutive sequence that we have got. So if our previous element plus 1 is equal to the current element, then we'll increase the count or we'll reset the count to 1. And our max would be max of mx comma whatever the length is, and our count would be equal to this mx being equal to 1. So if like max is 1, then we'll say that the count, like this count, will start the count by 1. Otherwise, we'll start the count by 0. Then like this, we'll simply calculate the count. So what are we doing here? If this sequence, if like the previous element plus 1 is equal to the current element, we'll increase the count by 1. Otherwise, we'll reset the count to 1. And if at any point the count becomes equal to the max, we'll say that, okay, we got another array with the exact same length. So we'll increase the count by 1. Our answer would be 2 raised to the power L minus 1 into, this is simply calculating the n minus L factorial. And here is the multiplication with the count, and we're just simply printing it and taking the modulo everywhere. That's the whole solution in C++. Now let us see the solution in Python. So we'll begin by running a loop for each test case. We'll take in the input of n and the array A. We'll sort the array A. We'll find the maximum length of consecutive plus 1 sequence. We'll begin by setting this max equal to 1, which is the maximum length. And current will store the current length of the consecutive ones. If the previous element plus 1 is equal to the current element, we'll increase the current by 1. Otherwise, we'll reset this current to 1. We'll say that the maximum length that we got is equal to max of mx comma current. And then we'll count that how many such maximum sequences appear. So that will store in the count. So if count, it would be equal to 1 if mx is 1, otherwise 0. We'll begin by current equal to 1. Now over here, max is equal to 1 just to kind of handle an edge case where if mx is equal to 1, then we're setting count equal to 1 because we're starting the iteration of this I from I equal to 1. Right. Now if a of I minus 1 plus 1 is equal to the a of I, then we're increasing the count of our current array, like this current integer. Otherwise, we're resetting this current to 1. And then if current is equal to max, we'll increase the count by 1 because we got another sequence which is of this maximum length, right? Over here, we're just calculating our answer. So answer is equal to this binary power of 2 comma mx minus 1. And then we are just calculating this n minus l factorial. And over here, we're just multiplying our answer with how many such arrays appear. And then we're simply printing our answer. That's it for this solution. The time complexity of both the C++ and Python codes are bigger often. And that's it for this video. I hope you liked it. Thank you. Bye-bye.